Welcome everybody, welcome to this summary series. Today we are going to discuss amines. Amine chapter is a very short chapter compared to any other chapter in organic chemistry included in your class 12th curriculum. So without wasting time, let's begin our chapter everybody. This is your teacher Dr. Lakshya Kathuria. So far we have discussed various organic functional groups, for example, alcohol, phenol, ether, aldehyde, ketones, carboxylic acid, carboxylic amide, esters, anhydride, acyl chloride, so many. But today is the time for amines. So let's begin with amines, everybody. So what are we going to discuss? In the very first step, we will be talking about some of the method of preparations and properties of amines, right? Don't call it amine, please. Amine is a bad word. Not bad in that sense, but yes, its pronunciation is amines, not amines. I'm sure you know this substance or this. If I ask you to pronounce this, I'm sure many of you will be pronouncing it as a vitamin, but that's the wrong pronunciation. It is vitamin. It's made up of two words. One is called vital and the other one is amines. So what do we understand from this separation of the two words? That some substances of some chemical compounds made from amines are vital for our life. Those are called vitamins, and you know vitamins are extremely important for our growth, for our survival, for any sort of biological function, right? Vitamins are very important. We will also discuss some of the method of preparation of aniline. What is aniline? Aniline is an aromatic compound, one of the NH2 group present on benzene. This is known as aniline. Then we'll discuss some properties of it and then some modifications done on aniline. Those are specifically diazonium compounds. Let's begin. Very first thing to be discussed is some preparation of amines. Huh? So how do? We start from, as usual, I have brought to you entire NCERT plus some reactions required for your NEET as well as for JEE Mains examination. If you just go through this video for today, every single reaction will be covered. Every single reaction. Just download this, just prepare from this video and you are done. Right? Plus practice, obviously, plus some practice. So I start from reaction number 1, that is RNO2. So nitro reactions, nitro compounds. So what do we do to nitro to obtain this compound? So the reaction says, if you start with RNO2, we need to reduce it to NH2. Sir, how do you know it's a reduction reaction? See, classical chemistry definition of oxidation and reduction are so simple. Removal of oxygen is oxidation. Addition of hydrogen is, removal of oxygen is a reduction reaction. Addition of hydrogen is a reduction reaction. Increment in oxidation state, decrement in oxidation state, all sort of processes we know are actually reduction or oxidation processes. That is a part of redox reaction. So RNO2 is reduced to RNH2. What is this degree, guys? Let me explain to you the degree of amines first before we begin. If you have one carbon containing compound attached to NH2, this is primary. Suppose this is CH3. CH3NH2 is known as primary amine. Right? If I now substitute the other valency of nitrogen also with CH3, this becomes my secondary amine. Okay? And if also I substitute the third hydrogen by CH3, this becomes tertiary amine. What does it become, guys? Tertiary amines. Remember, there is a pair of electron present on nitrogen to beautify it. Okay? There's a pair of electron present on nitrogen to beautify it. These all fall in the category of bases. Nitrogenous bases. What kind of bases, guys? Nitrogenous bases. Okay? Right. Then, what were we discussing? We were discussing about how to convert RNO2 to RNH2. Very simple, guys. We need nascent hydrogen here. And the source of nascent hydrogen will be upon dissolving or upon reacting a metal with acid. We can take tin, we can take zinc. When you react or when you add tin or zinc in HCl, both of them are going to liberate nascent hydrogen, and that nascent hydrogen will be responsible for this reduction. Is the reaction number 1 clear, everybody? Is the reaction number 1 clear, everyone? Is the reaction number 1 clear? Okay. Now I have alkyl azide. Generally alkyl azides are of nitrogen. There are 3 nitrogen present. Obviously there will be a charge. What kind of charge? Let's figure out. Nitrogen requires to form 3 bonds. So Rn, another nitrogen, and there is a nitrogen present here. Sir, nitrogen has formed 4 bonds. Yes, therefore it is going to get a negative charge. So this nitrogen has got only 2 bonds. Yes, so it has to get a negative charge. Overall it is written as neutral, Rn3. Rn3. So this is known as Rn3 sodium, or you can say it's alkyl azide. Alkyl azide. So we have heard of metal azides. What are those? Can you explain once? Yes. Suppose I remove this carbon based compound and put over here a metal, right? So out of carbon and nitrogen, which element do you think is more electronegative? Sir, obviously nitrogen. So upon breaking this bond, I should deliver a positive charge to this and negative charge to the nitrogen. So I want to replace this electropositive site with metal. Metals are also electropositive. So let's keep sodium here. Sodium plus, and then nitrogen. This nitrogen will have a negative charge. There will be nitrogen positive. Double bond nitrogen has a negative charge. You can draw its various resonating structures. This together makes it neutral. This negative and positive, they are together. This is what you write as sodium azide. There is another compound, barium azide. Very useful compound. I want you to tell me in the comment box, where do you see, where do you use barium azide? Right? This is from your S block chemistry ka question also. Very oftenly it is asked in JEE mains as well as in NEET examination. So you have to tell me in the comment box what is barium, or where do we actually use barium azide. Let's come back to amine processes. All right. So alkyl azide also by the reduction can be converted to primary azide. So what are the reagents required for that? So metal and hydrogen based, this is heterogeneous catalysis. Lithium aluminium hydride. Lithium aluminium hydride can also be used as a hydride source. So that will also be acting as a reducing agent. Make sense? Now after finally the reaction is over, then you add H plus or water, right? So then the product obtained will be primary amine. Here also we made primary amine. Here also we created primary amine. This is an important reaction and I have discussed this already once in my previous lectures. So how do we do that? What is the funda behind it? What is the reaction going on here? So let's see that. RC triple bond N, RC triple bond N upon reaction with hydride. What's the source of hydride here? So hydride can come from lithium aluminium hydride, or we can use sodium borohydride. Although sodium borohydride is a weak reducing agent, but upon increment of the temperature can actually help in reducing cyanides or nitrile also. So hydride would like to go and attack on the carbon positive center. This is my nucleophile. This is the electrophilic center in this whole molecule. Obviously this pi bond should open up. This pi electron should go back to the nitrogen, and carbon now has a new bond made with hydride. So what is the source of this H? What is the source of this H? Sir, LaH, lithium aluminium hydride. Once this reaction is over, what are you going to do? You will add water or H plus, acidic water. Mild acid is required. So this negative charge is going to take up this hydrogen. The compound obtained is R, C double bond, NH, and there is hydrogen already present. Recall guys, recall, I told you that this compound is water sensitive. Water sensitive. Upon addition of water, you will obtain this compound. You will obtain an aldehyde. You will obtain an aldehyde plus ammonia. This is one way of reacting. But did you get an amine here? No, you have obtained ammonia here. Did we intend to prepare ammonia or amines? We are going to make here amines here, or amines over here. So what am I going to do here? I will, from this reaction, in this reactant, I will again add one more set of lithium aluminium hydride. So this is going to produce, again hydride will go to the positive center. So carbon double bond now becomes a new this hydride, this H minus will go again on this center and break this molecule. So what are you going to obtain now? This will be RCH. Nitrogen already had a negative charge. Now it has 2 negative charge. Now you add water. Carbon double bond nitrogen is weak, is water sensitive. Carbon single bond nitrogen is a strong bond. Doesn't happen to it. Nothing happens to it. So R upon the addition of H plus in water, what will you obtain? You will obtain your primary amines. And also it is now justified. Why do you get primary amine? Can anybody tell me in the comment box what is the source of these 2 hydrogen? What is the source of these 2 hydrogen? Earlier we have figured out that this hydrogen is from lithium aluminum hydride. So what will be this? This is also obviously coming from lithium aluminum hydride. Finally, the answer yet that you have to deposit in the comment box is, what about these 2 hydrogen? From where are these 2 hydrogen coming up? Okay, clear everybody? Let's proceed to the next reaction. So this is also done. Remember, cyanide can be treated, can be reduced to amine. Remember, first step has to be completely done. If you add only 1 equivalent of lithium aluminum hydride, 1 equivalent means for 1 molecule, 1 of this, then the reaction may not be completed. The reaction may not go into the desired path, or the compound obtained will never be primary amine. It will be ammonia instead. The next reaction, as I was telling you, cyanide can also be treated with sodium in the presence of ethanol. Do you remember sodium and ethanol can react together to produce electron, right? Hydrogen can also be produced. Hydrogen gas will be also produced. If you want to test any molecule has an acidic hydrogen or not, just react it with a reactive metal, active metal like sodium, alkali and alkaline. Generally we choose alkali metals. So these 2 are going to react to produce alkoxide, C2H5O minus Na plus, and hydrogen gas will be liberated. This hydrogen gas liberated will be used for the reduction, will be eventually used for the reduction, and then the path followed is the same. Carbon and nitrogen, both of them are going to receive 1 H first, 1 hydrogen will be H, 2 molecule will be added, and the next CHNH is produced. Again 1 more molecule of hydrogen gas will be added. Understood? How do we get this? The name of this reaction is Mendes reaction. Remember, the name of this reduction reaction is called Mendes reduction. Okay, this reaction is again very simple. What do we do over here, guys? We start from, what is the reaction? RMgX, and then we have RMgX reacting with RNH2. RNH2, or what is it? No, we have to prepare RNH2. So this is my chloro NH2. Very good. This is R minus, which will attack on this, what is it? Cl NH2. Great. So it will attack on this center, Cl will get out, and the compound obtained will be RNH2. And then magnesium will be sitting with another Xn chlorine. This is the magnesium salt. This is the magnesium salt produced. What is the nature of this alkyne? This amine. This is primary amine once again. Sir, why primary? Because the nitrogen has only 1 carbon based group attached to it. Are you guys following? Shall we proceed? Okay. This reaction, this compound is known as isocyanide. RCN is alkyl cyanide. And when you reverse the connectivity, the connection between carbon and nitrogen here names this molecule as isocyanide. Isocyanide can also be reduced with the help of the same set of reagent, lithium aluminum hydride. The compound obtained would be this time secondary amine. Sir, why secondary amine? Because nitrogen has this bond with carbon here. This is carbon. Generally you can show this as N plus Nc minus. Now you are seeing that carbon is this time minus. So lithium aluminum hydride, where do you suppose to send this hydride? Sir, here. And this carbon will be receiving this pi bond. Eventually 1 more hydride will come and it will push this hydrogen, push this double bond also to the carbon side, and then there will be RNHCH3 formation. This is reduction of isocyanide. I hope all the reactions are clear on this page. Clear, everybody? Shall we move to the next slide? Shall we move to the next slide? Okay, let's proceed. The second set of reactions that we need to do is preparation of amines. We have to start from aldehyde ketones. You know aldehyde ketones very well now because we have discussed a lot of reactions of aldehyde ketone, and I remember telling you that our C double bond OH can be reacted with this sort of amines. These are known as derivative of amines. What you need to do is just the dehydration reaction. Upon dehydration means removal of water, you obtain carbon, hydrogen, double bond, nitrogen Z. So now it seems like we have generated Schiff base, some sort of Schiff compounds. Yes, this is known as Schiff base, or imines, or aldimine, ketimine, semicarbazone, all sort of carbon double bond nitrogen compounds. They are water sensitive. Remember, they are water sensitive. So when you have to do the synthesis of carbon double bond nitrogen, you need to prevent any water contamination. It should be entirely free of water. It should be entirely free of water. Let's go here. This is known as hydroxylamine. This is known as hydroxylamine. Now this NH2 and this oxygen, they two are going to get out. They two are going to get eliminated, and the compound obtained will be carbon double bond nitrogen. This is known as oxime. This compound obtained is known as, this is the class of organic compound named as oxime. Very important molecule. Now there is a carbon nitrogen double bond. I want to reduce it. How can we reduce it? Again, let's use some sort of hydrogen source. So carbon nitrogen bond, once it is made to carbon R and R dash, single bond nitrogen HOH. This compound is not very stable. So what we do, we treat it with zinc HCl. Upon the treatment, this oxygen gets taken care by zinc. Zinc is a scavenger of oxygen. What does it mean, scavenger, guys? Zinc is a sink for oxygen. If there is any oxygen present in the reaction vessel and you want to get rid of it, use zinc. I'm sure you remember one of the reaction starting from phenol. I want to prepare benzene from phenol. What do you use? Remember, zinc dust. Just use zinc dust and the compound obtained will be without OH group. This is known as removal of OH. Why? Because zinc is oxophilic. Zinc loves oxygen. If oxygen is present somewhere, it will trap it. It will absorb it. So now we can remove this NO bond easily. Are you guys following? We can break this bond nicely. And the compound obtained will be again primary. So you in your examination, in board examination, the examiner might ask you, write down a few method of preparation of primary amines. You can include this one as one of the methods. Okay. Now the second method is when we start from R-NH2, similar kind of mechanism. Sir, here R seems to be R seems to be equals to OH. That's the only difference. Otherwise, exactly same thing. See this OH R dash dash. Right? Could you understand? There is only one difference. Instead of R double dash, here I have used OH. This compound is specifically known as imine. Carbon double bond nitrogen bonds are imines. Imines, I-N, imines. Lithium aluminium hydride, again hydride source. Very simple chapter, guys. This chapter is extremely simple. All the reactions are similar. Hydride will try to go to the carbon center because carbon has a delta positive charge and nitrogen will receive the negative charge. That negative charge will be satisfied later by hydrogen plus from water or from H plus source. This is my secondary amine obtained, right? Similarly, I can start with secondary amine, which will produce this iminium salt. Iminium, why? Because there is only one hydrogen present, and to make carbon double bond nitrogen has to form 4 bonds. To 4 bonds, now the nitrogen will be positively charged. This is iminium salt. Okay. Now this molecule is known as sodium. There is triacetoxy borohydride. Triacetoxy. So let me write the structure of this molecule. We know sodium borohydride. Sodium borohydride. And what is the reagent used over here? Sodium boro. Instead of all the 4 hydrogen, there are 3 acetyl. So sodium, boron, and there are 3 acetate present, and this is a hydrogen. So if anybody asks you the structure of sodium borohydride, you can immediately draw this structure. There are 4 hydrogens around boron, and then overall charge here is negative, 1 negative charge. Similarly here, sodium plus, boron has OC double bond OCS3, 1 acetyl group, 4 acetyl, है ना? 4. There are 3 acetyl groups around. There are 3 acetyl groups around boron, and the 4th valency is fulfilled by hydride. Therefore, again overall 1 negative charge, sodium. This is also one of the reducing agent. Mild reducing agent, but nice, very nice, very nice. So let's go back. Now we are using this mild. You can use sodium borohydride also, and the resultant obtained compound will be tertiary amines. Tertiary amines. This way you can distinguish between primary, secondary and tertiary amines. You should know the starting material for all the 3 kind of amines is ketone. All the 3 is ketone. Starting from ketone, RR dash. You have RR dash here in the resultant compound also. You have RR dash here also. RR dash here also. So what is the change basically? The change is in the amine with which you are reacting. If you reacted with hydroxyl amine, primary. If you reacted with primary amine, secondary. If you reacted with secondary amine, then tertiary. So it seems like it's a chain. It's a chain. Yes, it's a chain. What we can do? Starting with the ketone. Organic chemistry is so interesting that you can create many compounds starting from just one. This is what the derivatization is called, right? You can make many compounds just by making some derivatives of a compound. So ketone can be reacted with an H2OH. The compound obtained will be oxime. Check please. The compound obtained will be oxime, right? Now you reduce it, reduction. This way you should be practicing. This way you should be creating some mind maps and then try to understand the reaction, not memorize. Compound obtained will be primary amine. Once you obtain a primary amine from this reaction, I would like to take the same. I would like to take the same or a different ketone, a new or maybe the same, whichever is available in the laboratory. React with the product of the first reaction. Compound obtained will be secondary amine. That secondary amine can be treated freshly with the new or the same ketone, and the compound obtained will be tertiary amines. This becomes one of the method of preparing different degree of amines in the laboratory. This goes via amine, and this goes via iminium salt. Okay, interesting. One information I want to give you, that nitrogenous bases are bad for men. You should know that. Prolonged use of nitrogen bases like pyridine. Since we are studying this chapter, you should know that. Also you can think of triethylamine. Triethylamine. Not chai. This is triethylamine. So triethylamine will be nitrogen with 3 ethyls around it. This is bad for men. Not one or twice use. This has to be a prolonged use of many years. Then this can be proven bad for men. Okay, good. Let's proceed. So we were here. We have discussed all the reactions. I hope all the reactions of primary, secondary, tertiary amine preparation is well enough, good enough, understood. Let's go to the next part. Okay, let's discuss some more preparations of amine. This reaction is one of my favorite reaction, and it should be your favorite too. Why? Because this is favorite of board examiners also. This is known as Gabriel synthesis of primary amines, specifically primary amines. This method cannot be used to prepare secondary or tertiary amines. Excellent method, by the way. Excellent method of preparing primary amines. Starting from phthalimide. If you look at the difference between the reactant and this product, it has some benzene with 2 acid framework, which is converted into amide. Let me tell you how do we do that. We start with phthalic acid. When there are 2 carboxylic group present on the benzene ring, one after the another. There is position number 1, that's position number 2. This is known as phthalic acid. Suppose I have 2 carboxylic group present para to each other. This is known as terphthalic acid. Remember, that's the difference, terphthalic acid. These two are different from each other. These two are isomers, but they are different molecules. They have different reactivity. Reacting it with ammonia produces phthalic anhydride, thalamide, C double bond O NH, and then we have C double bond O NH. This is known as thalamide. See, this is amide, cyclic amide. This side also, the other side also. There are 2. This nitrogen is participating in this group as an amide group, or the top one also as an amide group. It's a cyclic amide. Correct, everybody? It's a cyclic amide. Okay. Now, once we react this molecule with KOH, this nitrogen will become negative because there will be acid-base reaction. This is a base, and this nitrogen can be lost in the form of H+. So why? Nitrogen containing compound with hydrogen should be basic in nature due to the lone pair. Yes, but this nitrogen minus upon this hydrogen losing, when this hydrogen is lost, this negative will be in stabilization, will be in conjugation with C double bond O, and that makes it a nucleophile. This nitrogen nucleophile will react with Rx. I can choose R of my own choice. Whatever R you want to choose, alkyl halide, there will be pure SN2 attack. There will be pure SN2 reaction, and the compound finally obtained will be R from your choice. There are 2 R going to be coming there. And sorry, there will be 1 R and there will be an H2. This is known as a primary amine. So this is Gabriel thalamide reaction, which is used to prepare primary amines. Understood? We have to actually prepare thalamide starting from phthalic acid itself. And when you do this reaction, this is the method for preparation of primary amines. Second method, amide can be treated with X2 and NaOH, or in short you can say NaOX, because these two are reacting, these two will react together to produce NaOX. Okay? Although it depends upon the concentration of NaOH. Let me write that equation also. If you react X2 with NaOH, if it is dilute and cold, then the compound obtained is NaCl plus NaO, not Cl, NaX plus NaOX. Suppose X2 react with NaOH, then it's concentrated and hot. So the compound obtained will be NaX plus NaXO3. So I'm going to ask you a question, guys. Answer the oxidation state of this halogen in this compound, oxidation state of this halogen in this compound. Repeating my question, what is the oxidation state? What is the oxidation state of halogen of X here and here? Question, answer in the comment box. Tag me and tell me the answer. Okay. All right. So this is known as Hofmann bromamide degradation. Hofmann bromamide degradation. Sir, why degradation? I'll explain. Hofmann bromamide degradation. Because you are degrading. Some of the reactions are going to come again in the same discussion, so you should get yourself comfortable with what we have discussed already. So this is degradation of this amide. Amide has lost its C double bond O. Carbonyl C double bond O, this is completely lost. And what have you obtained? This is without C double bond O. See this? What's the difference? R is as it is, NH2 is as it is. So this is primary amine. Again, an excellent method of preparing primary amines. The question also comes, what is the side product obtained? What happens to C double bond O? Basically, C double bond O becomes sodium carbonate. Sodium carbonates. And this is what I said, when you react X2 with NaOH, NaOX forms, also NaX forms. Clear, everyone? Okay. The another reaction is very simple. This is SN2 attack. So let's go back and discuss this. RNH2. This is a pair of electron. This is a nucleophile. This is a nucleophile reacting with acyl chloride. RC double bond O Cl. This is leaving group. Lg. In short, I'm writing leaving group. This pair of electron goes in attack here. This is a leaving group, hence it has to leave. And the compound obtained is amide R, C double bond O and H2. Very simple SN2 attack. Pure SN2 attack. Pure SN2 attack. Then what are we doing next? Once this amide is obtained, what we will be doing? We will be reacting it with NaOH. In the presence of NaOH. It is done in the presence of NaOH. So RNH2 has already attacked here on the center, and the compound formed is the secondary amine. Let's see what we do. What did we do here? So this was NH2 here, and it already had R present. So this nitrogen is going to lose. Let's say it is R dash. This nitrogen is going to lose one of the hydrogen to be neutral. So R, C double bond O, NH, R. So this is my primary amide. R, C double bond O, NH2 is known as primary amide. R, C double bond O, NH with one R group is known as secondary amide. R, C double bond O with two R groups present is known as tertiary amide. Remember, tertiary amide. This classification also should be clear. So what did we obtain from this whole reaction? Secondary amide, not amine. Amide. Secondary amide is obtained. Now what do we do next? What are we supposed to do next? We will be repeating a reduction reaction. Lithium aluminum hydride. So what is this lithium aluminum hydride is going to do? It will try to reduce C double bond O to the hydrocarbon. Clear, everybody? Clear, everyone? Then we can do reduction to obtain amine. All the reactions are clear on this page, everybody. So first reaction is very important. This entire slide is very, very, very important. Make your star, moon, earth, whatever you want here. This is very important. It's like Gabriel phthalimide process, and then Hoffman bromide degradation reaction, and finally the reaction using primary amine, we can prepare secondary amine. Can we use this molecule? Can we use this as the starting material? Can we use this as a starting material? Yes. Should we try that? Let's do that. What I'm trying to say, I want to use this material after the reduction as the starting one. So I have R, CH2, NH, and R group. So there is a pair of electron present. Again, there is a pair of electron present which can be used to attack on C double bond O of carbonyl of acyl chloride. This chlorine leaves immediately, and then compound obtained is RCH2 NH with a new bond made with C double bond O Cl. Cl is gone. The Cl is gone, and this is R. Let's say this is R dash. This is R dash. Nitrogen is carrying positive charge. Nitrogen is carrying a positive charge. This nitrogen had R also. This nitrogen has R also. Now this hydrogen will drop its electron to be neutralized. This nitrogen will be made neutral. So R, CH2, nitrogen has R group, has C double bond O, R group also. So what am I going to tell this molecule as? This will be tertiary amide. Now this tertiary amide can also be reduced by lithium aluminum hydride to obtain tertiary amine. RCH2 NR CH2 R group. This is my tertiary amine. There are various methods of preparing primary, secondary and tertiary amine. We have discussed all of them in this today's lecture. Okay, everybody, let's go back and confirm if you have understood all the preparation method. So what have we discussed so far, everyone? What have we discussed so far? We started with the preparation of amines. We started with the preparation of amines. That is a straightforward reduction method. Reduction method of nitro. Wherever you see nitro, the question is basically about the reduction. Okay? Whenever you see a nitro compound given, there is a chance that the question is about reduction of NO2 to NH2. Nitride or cyanide, they can also be nitrile or cyanide can also be asked to reduce it. We have learnt in aldehyde ketone chapter that they can be partially hydrolyzed to amide, fully hydrolyzed to acid. They can be reduced to amines, primary amines. Cyanide can again be reduced by another set of reagent that is known as Mendes reaction, where we use alkoxide, sodium alkoxide in alcohol. This is pure SN2 reaction to produce alkyl amine. And then we discussed a reaction with alkyl azide. You can prepare a primary amine of your choice. This is also secondary amine. Again, we can continue. Then we had discussed about the preparation of amines starting from aldehyde ketones, aldehyde or ketones. So if you start with aldehyde, what are you going to obtain? You will be obtaining NH2 with carbon, just one carbon here, R, and then there will be hydrogen present. Right, everyone? Okay, let's proceed. This was the next part. I told this is very important for your board perspective. Please practice these reactions. You have to practice these all of these reactions once by your hand. Then you are going to do justice to yourself. Otherwise, you will be totally lost. There are so many reactions, and trust me, every reaction has the similar or somewhat. They have similar mechanism. You just have to look for an electrophile and nucleophile. Just do that. Just simply, just do that. Now let's try to understand this reaction number 1. So you are saying it's a very simple reaction, just finding out the electrophile and nucleophile. Show us here, please. Please tell us how to do that. Okay. There is this nitrogen having a pair of electron. This carbon and halogen bond is attached. Sir, you write it and explain. There is R and H2 which has a pair of electron, and I told you in my beginning classes how to identify nucleophile and electrophile. This will be the identification for a nucleophile. Either they should be absolute negative charge or a delta negative charge or a pair of electron or a double bond or a triple bond. What is the electrophilic? What is the identification of an electrophile? They should be either a positive charge or delta positive charge or incomplete octet. Incomplete octet. Okay. Chaliye to let's react it with, what are we going to react it with? Okay, here it is, alkyl halide. We have discussed haloalkane, haloarine also. If you have not watched that video, I will strongly recommend you to watch that also. Now this is my delta positive center. Sir, how did you know there's a delta positive center? Arey, RX bond re. R is a carbon based compound. Halogen is always more electronegative. Take any one of the halogen. They are all more electronegative than R. This attacks over here. This halogen has to leave. Carbon refuses to form more than 4 bond. Refuses to form more than 4 bond. R and H. There are 2 hydrogens already present. There is a new bond formed. Let's say this R dash. R dash. Nitrogen should be carrying a positive charge. Whenever you see carbon or oxygen having positive charge, they will try to neutralize themselves somehow. So here we can easily break this bond. Hydrogen will be lost. And once hydrogen is lost, R and H. R dash. So what have you done? Starting from primary, you could make secondary amine. Yes, please. Understood. Understood, everybody. So yes, can we do the same reaction once again? Yeah. Yes. Let's bring this pair of electron reacted with a new pair of R dash X. So this pair of electron, it's still a nucleophile. Yes, this X has to leave. Pure SN2 attack. So the compound, I'm already removing the hydrogen. Okay. I'm already removing the hydrogen. So this compound will be R dash and R dash. So let's use this once again. Let's use this once again. Wow, maza aa raha hai. Let's use this once again. R dash, R dash. Reacting with the R dash X. This pair of electron goes and attack here. X has to leave. And then the compound formed has a positive charge. There are 4 R groups present. 4 R groups around nitrogen. This is known as quaternary nitrogen. Quaternary amine. 4 degree quaternary amine. So let's do one more attack. No. Why no? There is no lone pair. Are positive charge. It's an electrophile now. It's a positive charge. It's an electrophile now. Is it an electrophile? No, it's not an electrophile. Sir, you said there is a positive charge. Those will be electrophiles. Yes, but But oxygen with a positive charge and nitrogen with a positive charge, be careful, they are not electrophiles. They are not electrophiles. They are not electrophiles. Just like pictures are deceptive, है ना? Pictures are deceptive. What does it mean, sir? Pictures may, you might think that this person is that, this thing is so beautiful, this building is so beautiful, but when you go really inside, do you find it or not? Then perspective will be different. Pictures are deceptive in nature. So what is this? Positive charge in case of oxygen plus and nitrogen plus, they are deceptive. धोखा देती हैं, they are deceptive. Why? How will you obtain positive charge on oxygen? How will you obtain positive charge on oxygen if it has already formed 3 bonds? If it is an electrophile, it should look for 2 more electrons. Chalo, let me bring in some pair of electron from, let's say, X. X comes, tries to form, as I said, nucleophile and electrophile, they should form a bond. Eventually they should form a bond. So oxygen ka X, and there are 3 hydrogen present. Tell me, is it possible? Is it possible for oxygen to form 4 bonds? Never, ever. Never, it is not possible. So then why is it not electrophile? Oxygen positive charge, there are 3 bonds made with hydrogen. There is 1 pair of electron also present, because this is actually made from water. Water had 2 pair of electron. How many electron does it have? How many electron oxygen has? 1, 2, 3, 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6, 7, 8. Its octet is complete. Its octet is complete. It does not need any pair of electron anymore. It doesn't need that. Also, oxygen plus is not an electrophile, not a nucleophile. Not an electrophile, not a nucleophile. Sir, explain nitrogen also. Are karo? Suppose this is ammonia. Ammonia is a nucleophile. Perfect, yes. But if I make 4 bonds, of nitrogen, what are you going to do? You will be making another bond with nitrogen positive charge. Is it having any lone pair anymore? No. Is it a nucleophile? No. Is it an electrophile? So there is a positive charge. Probably this is an electrophile. Let's try that. So electrophile should actually be able to accept 2 more electrons. But so nitrogen seems to have already 4 electrons, and nitrogen cannot form 5 bonds. Never ever in his life. Never ever in its life nitrogen can form 5 bonds. So nitrogen plus and oxygen plus, they are not an electrophile, not nucleophile. I hope this difference is clear. So then, tell me, if I bring another R-X, will there be any reaction? Will there be any reaction between this molecule and this molecule? No, this is not a nucleophile, not an electrophile. Reaction gets over. This is known as you have exhausted the nitrogen. You have completely reacted the nitrogen. There is no lone pair left on the nitrogen. Hence, this reaction is named as Hofmann exhaustive alkylation. You have completely exhausted the nitrogen atom by making its quaternary salt. Making it quaternary salt. Understood, everybody? Good job. Here I have showed you that the reaction is just secondary amine formation. This reaction, sir, we have just seen it. I told you that some reactions are going to be repeated. See this, the same reaction is same reaction is coming again. Same reaction, same reaction once again, already discussed. This reaction, sir, we know already, this reaction is a diazotization of aniline or primary amines. Diazotization. If you react it with NaNO2, another set of reagent used will be NaNO2 with HCl. This combination actually produces dilute. It produces HNO2, which is known as nitrous acid. As nitrous acid is very weak acid. Remember, it's a source of nitrosyl, NO+. It's a source of NO+. Okay. Primary amine can also be reacted with chloroform. It gives you carbyl amine. Let me write that. So you start with RNH2. Reacted with chloroform in the presence of KOH. The compound. Where else you see this set of reagent in organic chemistry? Write down, comment in the chat box. Where else you see this set of reagent? I have taught you already. I have taught you. Refer my previous videos for the answer. So this forms R. Suppose I had RNH2. It will form R and C compound. RNC, this is known as carbylamine. This is known as carbylamine. RNC is forming carbylamine. This gives you very, very bad smell, very bad, intolerable smell. You cannot tolerate. This is known as carbylamine test. What is it this test for? Particularly for primary, only for primary amines. This test is not possible to be done for secondary amine, not for tertiary amine. This becomes a practical organic chemistry. Then they can ask you a question: how do you identify in a laboratory setup, how do you differentiate between, or how you distinguish between primary, secondary and tertiary amine with the help of carbylamine test? Secondary one doesn't react, tertiary doesn't react. Now this is again my primary. If you want to oxidize, remember I told you in the class, in the beginning of the class, removal of hydrogen is also oxidation. So what am I doing here? Oxidation. Both the carbons, but this carbon nitrogen, they are leaving their hydrogen and forming aldyne. Why aldyne? This also I had explained to you. If your starting material is, this material makes aldehyde upon hydrolysis, will be called aldyne. See this here, after hydrolysis, aldehyde and ammonia. Aldehyde and ammonia. This is my another kind of, this will be my R2CHNH2. This oxidation gives you ketimine because the starting material comes from a keton. I'm hoping that these things are getting into your head. Okay. Then you can take secondary amine. Secondary amine can be oxidized, but then this results into this results into nitrogen-nitrogen bond. This results into nitrogen-nitrogen bond. Hydrazine. NH2 is hydrazine. Let me write this. So NH2, this is known as hydrazine. Suppose I start with R secondary amine, treating it with KMNO4. KMNO4 is an oxidizing agent. What is it supposed to do? Oxidize. So we will be bringing another molecule of secondary amine, and remove hydrogen. So basically we have to couple nitrogen and nitrogen. So the compound obtained will be R, nitrogen-nitrogen bond formation. Both the hydrogens in hydrazine, all the 4 hydrogen in hydrazine are substituted by alkyl group, so it's known as tetraalkyl hydrazine molecule. Sir, what about tertiary? Let's take tertiary. If I take R, N, R, R, now treated with KMNO4. So there is no hydrogen to be removed. What do? There is no hydrogen to be removed. So what is going to happen? Nothing. No reaction. KMNO4 cannot oxidize tertiary. This again becomes one of the method. KMNO4 ka color will remain as it is with reaction with tertiary amine. Tertiary amine do not react. So the color of KMNO4 will remain as it is. But in the case of primary and secondary, the color will be disappeared. ठीक है? Okay. This is known as a Carrow's reaction. This is known as the reaction with Carrow's acid. What do we do here? We start with R2. We start with R2 NH. This is my secondary amine, treating it with H2SO5. That's your Carrow's acid. The compound obtained, this oxygen gets inserted in between these two. This is my nitrogen OH-R. This is the compound obtained. This is the oxidation process. This is an oxidation process. So dialkyl hydroxyl amine will be the product. Understood? Sure, everybody. Let's discuss something about Carrow's acid. How do we know structure of, I want you to practice the structure of H2SO4 and then practice structure of H2SO5. H2SO5. I will be asking you a couple of questions from here. Structure number 1. For H2SO4, the name of it is sulfuric acid. Sulfuric acid. By algebraic method, what is the oxidation state of sulfur? Sir, hydrogen is +2 because there are 2 hydrogen present. So let me explicitly write +1 for hydrogen. How many hydrogen? 2. Plus, I don't know for sulfur, let's consider X. Plus, there is -2 for oxygen, and for how many? For how many oxygen? There are 4 oxygen atoms present. Overall charge is 0. This is known as algebraic method. This will be 2 plus X minus 8 equals to 0. X is equals to 6 plus. Sulfur can max tolerate, highest oxidation state tolerated by sulfur is 6 plus. Therefore, If your oxidation state calculated by algebraic method comes out to be equals to the highest oxidation state, yes, your compound has this molecule, this structure. Your compound will have this structure. Calculate by bond method also. 1, 2, 3, 4, 5, 6. This is 6 plus. Oxidation is 6 plus. Let's do the similar kind of calculation here for the sulfur. Now plus 1 again for hydrogen, plus X for sulfur, minus 2 and 5 for oxygen equals to 0. This will be plus 2 plus X minus 10 equals to 0. X comes out to be equals to how much? 8 plus. Am I right? Is my calculation okay? If you get your oxidation state greater than the highest oxidation state, which is 6 plus, then your compound will definitely have peroxy linkage. Your compound will have peroxy linkage. This SOOH is known as peroxy linkage. Rest of the compound will be same, ditto, same, exactly same. Let's count the number of oxygen atoms that you had here. 1, 2, 3, 4. Let's count the number of oxygen atoms that you have here. 1, 2, 3, 4, 5. Now the oxidation state, sir, 1 bond, 2, 3, 4, 5, 6 bonds. 6 bond, that means 6 plus. Therefore, algebraic methods are not always right. 6 plus is the oxidation state. This oxygen is basically getting inserted. This is known as peroxy. This is Carose acid known as peroxy sulfuric acid. Carose acid per sulfuric acid. Per sulfuric acid. Okay. So this oxygen will be utilized to insert in between these two bonds. Here, in between here, nitrogen and hydrogen. So this gets inserted here, oxygen. So what's the source of this oxygen in the molecule? Peroxy acid, Carose acid. Understood? All the reactions are done, guys. From this page, all the reactions are done perfectly. Pakka. Shall we move forward? Lovely. Pause the reaction, guys. Wherever you think there is a difficulty, pause the video and then try and understand. Let's try to understand some more reactions. Now we have properties of amines to learn. Property of amine says that there is a very important reagent named as Hinsberg reagent. I would like to explain this by writing there will be pH. What is pH? What does pH stand for? pH stands for benzene, sir. Benzene or phenyl here. Phenyl. Phenyl group is present here. Let's react it with primary amine, RNH2. There will be a pair of electron here which will attack on this. So by now you must have understood what to do in the reaction, how to identify nucleophile and electrophile. This is a electrophile, this is a nucleophile. So chlorine has to get away because sulfur cannot form 7 bonds. So the compound obtained will be pH with S double bond O, and then N has 2 hydrogens already present with a nitrogen. Nitrogen carries a positive charge. Sir, you said that nitrogen and oxygen, whenever they get a positive charge, they try to neutralize themselves. Yes, let's neutralize it. So the compound formed is pH S double bond O, one of the hydrogens present, and then R group here. Check out please. Starting from primary amine, reacting it with phenyl sulfuryl chloride. This will be having pH S double bond O Cl. This is known as Hinsberg reagent. Hinsberg reagent. This is known as Hinsberg reagent. Now finally compound obtained has nitrogen and H bond. If I react it with NaOH, which is dilute NaOH. If I react it with dilute NaOH, which basically contains water. NaOH is supposed to react with the protic hydrogen. This will form a salt, acid-base reaction. This will form acid-base reaction. This will do acid-base reaction, Na, N minus and Na plus. This is a salt, and salt are supposed to be soluble in water. The compound obtained as a result of reaction between Hinsberg reagent and primary amine is soluble in water. Understood? Is soluble in water. Now, if I react this guy with secondary amine, can we directly write this reaction? Can we directly react the product? pH S double bond O. So there will be nitrogen and R, another R present here. Is there any protic hydrogen present? Sir, no. There is no protic hydrogen present. But is there any reaction going between the Hinsberg reagent and amine? Yes. The compound obtained, will it react with NaOH? No. This will be insoluble in water. Insoluble in NaOH water. Insoluble in NaOH solution. Right? Now the tertiary one. Sir, let's react it with tertiary. S double bond O Cl. Will it react with tertiary? R3N. Will it react with tertiary? No. No. This pair of electron is capable of reacting here. The Cl will get out. But how will nitrogen make itself neutral? How will it make itself neutral? Let's react that reaction. So pH. Every reaction makes sense, guys. Every single reaction makes sense. R3 nitrogen. This is a pair of electron. Attacks here. Cl tries to go back. And then pH. S double bond O. Nitrogen is seemingly to be forming salt here in the first step. This is the compound which is positively charged species. Cl goes away, but the nitrogen cannot make itself neutral. So the primary one forms a compound. Which is soluble in water. This is the compound with NH, soluble in NaOH system. This is N-alkyl benzene sulfonamide. This has an acidic hydrogen. Very important, guys. Very important reaction. The second one forms NN dimethyl. This is the compound formed. And finally, there is no reaction. So why is there no reaction? You see that, please. This is my R3N. What is this site? It seems to be that it is going to form this salt. So it should also be soluble. But actually, this reaction does not occur. This reaction does not happen. Why? This is the bulky nucleophile. This is a sterically crowded bulky nucleophile, and that does not get a chance to accommodate itself to available sulfur for the attack. This cannot manage to go in between the sulfur and oxygen. It cannot manage to touch sulfur. Hence, this reaction will not be possible. This becomes a poor nucleophile because of the steric crowding of R groups. Clear, everyone? Very important, Hinsberg. They will be asking a question on why and how primary, secondary, tertiary amines can be distinguished with the help of Hinsberg reagent. Primary will be soluble in NaOH, secondary will not be, third will not at all reacting with Hinsberg reagent. Once you obtain these reactions are done, primary amines, secondary amine, tertiary amine, you can also start with primary amine, reacting it with HNO2. You know very well this is a diazotizonium reaction, that it can be reacted with water. It can be reacted with water or H3PO2. This will produce a primary alcohol. You can also react it with R2NH. Here the nucleophile is H2O. Here the nucleophile is R2NH. You can obtain yellow oily drop. Yellow oily drop will be forming. Yellow liquid, oily liquid will be forming. That is an N-nitrosoamine. That is known as N-nitrosoamine. You can also react it with tertiary amine. Tertiary amine can also react with HNO2 to form the salt. Because that's a base and this is an acid. That's a base and acid. Now when you heat this, you can obtain primary alcohol. And then you can obtain the similar product obtained in the previous case. Clear, everybody? Okay. This reaction is known as Hofmann mustard oil reaction. Hofmann mustard oil test. Reacting RNH2, that's my primary. Remember, it's for primary. It's for primary amines. Reacting it with carbon disulfide will form this compound. Then reacting it with HgCl2 will produce alkyl isothiocyanate, which has mustard oil type smell. Secondary one doesn't react with HgCl. This secondary amine is anyways going to react with the CH2, but will not be able to react with HgCl2. Hence, there will be no smell, no mustard smell. Tertiary one will not at all react with carbon disulfide. So again, you can distinguish. There are so many practical organic tests in this chapter. Primary one reacts to produce the compound here, which has mustard oil type smell. The secondary one reacts up to this stage, but not with HgCl2. There will be no reactions. There will be no smell. The third one, tertiary amine, does not react with CH2 itself. The first step itself is failed. Understood, everyone? Pakka, sure. Mustard oil test. You should be able to write some few words about it. Okay. Then an aniline. Amine part is completely done. Now we have specifically to be discussed Aniline. Aniline is benzene with NH2. In the beginning of the session, I already told you, nitro can be reduced by various methods. Metal with HCl, metal with HCl. This is already reacted with metal and HCl. This is again a solution of metal and HNCl2. Every single component will be responsible of producing nascent hydrogen, and that will be responsible for the reduction of NO2 to NH2. Understood? Lithium aluminum hydride can also do that. This H2 and nickel combination, this is heterogeneous catalysis, can also reduce NO2 to NH2. Understood? Very good. This is my hydroxylamine. This also we have discussed already. Hydroxylamine upon treatment with SnHCl, again hydrogen. FeHCl, again hydrogen. TiCl2 with HCl, again HCl. SnCl2 with HCl, again hydrogen. Again nascent hydrogen. They all are going to just help in breaking this. Hydrogen will be delivered to both the sides. Are you following? Hydrogen will be delivered to both the sides. Okay, aniline is obtained. This nitrogen-nitrogen bond can also be broken with the same set of reagent. This nitrogen-nitrogen double bond can also be broken with the help of the same set of reagent. Now, you can start with chlorobenzene, treating it with ammonia, which is generally considered as a weak nucleophile upon a very harsh condition, 200 to 300 degrees Celsius, can be used as a nucleophile, and then chlorine can be kicked away. Chlorine can be kicked away to make this compound aniline. Okay. OH, we discussed OH treatment with ZnCl2 will take care of this oxygen. That will help us in breaking oxygen carbon bond, and then you bring in the nucleophile, that's ammonia, NH3, to fix it on the benzene ring. Okay. This Hofmann-bromamide degradation reaction we already studied. The CO can be eliminated in the presence of Br2KOH, and the compound obtained will be having no CO at all in it. There will be no CO. So these were the methods. You go through once, pause the video if you are going to revise it for once. All the reactions are done. Okay. Now here, this reaction is courteous reagent. By the name you should know, acyl chloride. This will be benzyl. This will be benzoyl chloride. So this compound reacted with sodium azide. I asked you a question, what's the use of barium azide in our life, in our daily life? Can be treated, can be reacted to produce aniline. This is again NH2 can come over here and attack this Cl2 goes away, and then reacting it with HONO. Hono means HNO2. HNO2 means diazotization reaction. Upon adding of water, you can obtain NH2. The next reaction is also similar. This time instead of the nucleophile being hydrazine, here we have hydroxylamine. Hydroxylamine that also produces this compound, the same compound obtained. Zinc and HCl will be again a combination of the two metal and HCl producing nascent hydrogen. You can break this bond. You can break this bond to produce. Aniline. This reaction is very simple. pH. We have discussed this already. pH MgBr, treating it with ClNH2. This is negative charge, delta negative charge will attack on this nitrogen center, and this chlorine has to leave, and then pH NH2 bond forms. This is my nucleophile, this is an electrophile. There is a bond formation between the two. Clear, everybody? Okay, the last one also is very important. I have discussed this sometime before. Let me discuss this once again. So please pay attention what is going on here. Sodamide and liquid ammonia. All the important reactions I am separately writing down. So there is reaction with sodamide. NaNH2 is known as sodamide. Na plus NH2 minus, very strong base. What it does, it reacts with this hydrogen which is present at the beta hydrogen. This reaction is beta hydrogen. Now once the beta hydrogen is liberated, it will form a benzene type mechanism. It will form, this hydrogen is liberated. I have just moved the double bond composition, so do not worry about it. Or let me fix this so that you guys are not confused. Okay. There is this double bond, hydrogen is present here. There is a Br. Right, now perfectly okay. This hydrogen is lost in the form of hydrogen plus, leaving behind pi electrons. This pi electron will form benzene as an intermediate. Benzene as an intermediate. Now NH2 comes back. NH2 minus comes back. This can open up with this pi electron to either of the carbon atom. Suppose it opens up to this side, so NH2 will attack on the positive center. This is my NH2. This is a negative charge. There is a double bond already, double bond, double bond. Now add H plus. Finally, in the presence of water, you will obtain aniline. You will obtain aniline. This hydrogen, what's the source of this hydrogen? Acid. Okay. This is known as SNAR, nucleophilic substitution reaction on aromatic ring. Nucleophilic substitution reaction on aromatic ring via elimination addition method. Via elimination addition method. Elimination addition method. See, you have not directly kicked away chlorine or bromine. You have not directly kicked away. The NH2 is not attacking on this center to kick away this. It's not happening over here. You are actually doing elimination addition reaction. So first you are eliminating this hydrogen. Bromine is also eliminated. Then you are adding NH2 and hydrogen. So two things are eliminated and two things are added. So this becomes my method. Second reaction, second method is via addition elimination method, AE method. This was your EA method, elimination addition, and this is your addition elimination method or elimination addition method. So which method is being followed here, everybody? Which method is being followed here? We are removing this hydrogen from this position, beta position. That's elimination addition method. All the reactions are clear, everybody, on this page. Shall we proceed? Let's go ahead. Now we have aniline to be reacted with various reagents. This will cover entire organic chemistry, entire organic chemistry. By now you should know, this is base in nature. This is a base. This compound is a base. This has some basic nature. There is a lone pair present on it. This is also a nucleophile, plus this is a base. So base reacts with an acid. Base reacts with an acid. What does it do? Salt preparation, salt method. This is acid base reaction, salt. A plus B minus, A plus B minus, A plus B minus. So how many? There is a need of only one plus. How many of these are required? Two of these are required. So these two and sulfate. These two and sulfate. Total positive charge and the negative charge should be the same in a salt. Here also H plus and AuCl4 minus. Right? This is your gold compound, one of the rare compound of golds. Gold generally do not react. So there is overall a positive charge and AuCl4. This is an acid. This is a base. Sir, why is this an acid? Why are you reacting it with phenol? Is phenol an acid? Phenol are generally not an acid, but if you attach so many electron withdrawing groups, specifically nitro on ortho and para position to the phenol, this OH becomes extremely basic in nature. This hydrogen becomes extremely acidic in nature. This hydrogen and the NH2, they are to now start reacting with each other to form anilinium picrate. What is this molecule called? Picric acid. The name itself, the name is enough, guys. Picric acid. Although there is no carboxylic acid group present, yet it is picric acid. OH group is present. Due to the electron withdrawing nature, the oxygen minus is made highly stabilized. Okay. Now this is your CH3I, methyl iodide. This lone pair will attack on the carbon. Iodine has to relieve. And this is a pair. We have discussed this Hofmann exhaustive alkylation. This pair again attacks, will form tertiary, and this tertiary one will again attack to form quaternary. Quaternary will not proceed any further. There is no nucleophilic nature left on nitrogen now. This also we have discussed. This pair of electron will attack on the center. Cl will get out. There will be PH, C double bond O, and this molecule. That's an amide now. That's an amide now. All these reactions you should be doing it yourself once, at least once by your hand on a pen paper. You just should be knowing about the reactant and product and then try to write their mechanism, so that in examination, if you see any new reaction, you should not be surprised, right? Okay, let's come to this part. Again, HCl is an acid-base reaction. H2PtCl6, just like here, gold compound, platinum compound reaction. You can react it with CH3COCl, just like here we reacted it with PHCOCl, the same type of mechanism, same type of product. Answer the name of this compound in the chat box. What is the name of this compound? What is the name? What is the common name of this compound? Very, very important. What is the common name of this compound? You have to write in the comment box. Hinsberg reagent. Remember Hinsberg reagent? You have to react it with primary amines. Is this a primary amine? Yes. So they will react together to form a compound which is soluble in NaOH, aqueous medium. Now reacting it with CS2, this is a mustard oil test for again for primary amines. This give you mustard oil compound, mustard oil ka smell. This is your condensation reaction, H2 from here and oxygen from here. They both eliminate and form carbon double bond nitrogen. This is your Amine reaction. This is Amine reaction. These are specifically known as Schiff base, named on the scientist's name Schiff. We give royalty to the people who have discovered these reactions. So Schiff was the name of a scientist. Let's proceed, guys. Some more reactions, but the idea is the same. Now when I bring this molecule with C double bond O, C double bond OCl, Cl, and let me write it this way. Very important yet simple reaction, CCl, yeah, and H2. For the first reaction, one of the hydrogen and Cl goes away from here, and this nitrogen carbon forms a bond. One of this hydrogen and Cl goes away from here, and carbon nitrogen forms a bond. So there will be benzene ring here first of all, yes. There will be NH here, yes. Then there will be CO, yes. Then there will be NH, yes. Then there will be PH. Diphenyl urea, very important molecule, diphenyl urea. You can react it with NaH. NaH has sodium plus and H minus. It's a base. Base can react with this hydrogen to form a salt. NH minus Na plus. This is a set of the reagent I was asking you where else you have seen in organic chemistry. Carbyl amine test, specifically used for primary amines, not for secondary, not for tertiary. Same reaction once again. This is a pair of electron which will attack on this center of carbon. Chlorine will leave and then nitrogen carbon bond forms over here. Not very simple reaction, yet it is possible to be done at a high temperature in the presence of a catalyst. Now NaNO2 or HCl combination is diazotization reaction condition. The compound obtained is benzene diazonium chloride salt. We will be doing various reactions of it, various reactions of it. This was asked in your JEE examination once. If you treat it with very highly oxidizing agent, strong oxidizing agent, what happens to aniline? You form paraquinone. You form a paraquinone compound. Clear? Let's come to this side. Br2 in a non-polar solvent like CS2 or CCl4. CS2 or CCl4. The logic behind why to use CS2 or CCl4, we want non-polar solvent. Then there will be mono substitution, ortho and para. These will be the two products formation. If you use water is a polar liquid, polar solvent, one of the best solvent, mother of all the liquids, all the solvents. Then there will be poly substitution or multi substitution. Clear? This also we know HNO3, H2SO4 is known as nitrating mixture. Combination is known as nitrating mixture. You will do nitration here, NO2 here, NO2 here. This should be on ortho. This should be on ortho, not on para. This should be on ortho. Clear? Make this mistake correct, everybody. Do this correction. Then finally, the same molecule NH2 attacks on this carbon center. Chlorine has to leave. So let me explain this reaction by writing. Suppose you react NH2 with okay, yeah, CH3 C double bond O Cl. This is called protection of ammonia, protection of nitrogen. The double bond opens up here. When it wants to come back, there will be chlorine leaving. So then this compound is masked. This compound is protected. This nitrogen is masked. What is the meaning of masking? This is masking agent. This is masked NH2, masked NH2. The pair of nitrogen is masked here. Sir, how is it masked? Or protected nitrogen. Protected nitrogen. What is the meaning of protected nitrogen or masked nitrogen? Or the electron withdrawing, electron donating nature, electron donating nature, electron donating capacity or ability, capacity or ability is reduced. Ability is reduced in this molecule. Why do we actually want it to reduce? This nitrogen can activate the ring too much. This nitrogen NH2 activates the ring too much. So we mask it with C double bond O CH3 so that this pair of electron is not just involved in the conjugation with the benzene ring but also in cross conjugation with C double bond O. Therefore, it will get 50-50 chance to come in the ring and it will activate the ring less. Electron donation capacity will be, ability will be reduced. And then we can easily do nitration and produce one particular product, C double bond O CH3. We can obtain one particular product. Let's say this becomes my NO2 here. And then finally treating it with H+. Treating it with H+, we can break this amide. And finally, compound obtained is NH2, NO2. Can you reduce this NO2? Yes, by Mandy's reduction. We can reduce this. Using lithium aluminum hydride, we can reduce it. Using SN-HCl combination, using Fe HCl condition, using Zn HCl condition, we can reduce NO2 also. Let's go back and see this reaction. See this everybody. Now, acyl chloride was sticking to this NH2, making this ring less activated, and then nitration reaction is done so that to obtain NO2 here. Okay, then this reaction is very well possible to do. H2SO4 at 180 will do sulfonation reaction, SO3H on the para position. Clear everybody? Go through all these reactions once and make sure you have understood all these reactions. Clear? Shall we proceed everyone? Shall we proceed? Let's discuss some reactions of diazonium salt. You know diazonium salt can be treated with copper salts, cuprous salts, cuprous bromide chloride or cuprous cyanide. They can be used to prepare haloarenes. Haloarenes. You must have heard of Sandy-Meyer reaction, Getterman reaction. Cyanide can also be produced. If you want to produce iodide version of the molecule, iodide version of haloarene, you have to do this reaction with the help of Ki in the presence of copper iodide. And also if you want to specifically make fluoride, you have to treat it with HbF4. HbF4. Okay. Now this molecule can be used to attack in the presence of OH minus, can be used to attack and kick away this nitrogen. So carbon basically attacks on the center, forms CHO. What is the name of this molecule? What is the name of this molecule? Benzaldehyde. Benzaldehyde. This is your benzaldehyde molecule. Now phenol can also react. Let me explain this first of all. This is very important, very important. Suppose you have benzene diazonium salt prepared. First you understand where is the positive charge present. This is benzene diazonium salt with Cl minus. Reacting it with phenol, for example. Phenol has OH present. This pair of electron oxygen are not fixed. They are in motion. They're moving, by the way. And this reaches to the para position. If I write its resonating structure, you will realize that the electron density is very high. Electron density is very high on the para position, and oxygen is, by the way, not at all a nucleophile or an electrophile. This negative charge attacks on the center. Before it attacks on the center, the nitrogen pulls up its electron and forms another resonating structure. Where nitrogen is neutral, double bond, and this nitrogen is positively charged. This attacks on the nitrogen, forms a carbon-nitrogen bond. There's a double bond here. Carbon-nitrogen bond forms. So the product obtained is nitrogen double bond nitrogen with the benzene ring having every carbon has one hydrogen except this. So I'm writing hydrogen here. Double bond here, oxygen H with a positive charge. This hydrogen drops its electron here back. This pi bond moves. This pi bond goes back to the oxygen. Finally, the compound obtained is known as azodie. Azodie, nitrogen double bond nitrogen. And this has now double bond here, double bond here, double bond here, and OH is neutral. This is called azo dye preparation. This is called azo dye preparation. Understood? Clear, everyone? Okay. So this will be para attack always. Now you can start with a molecule which is carrying NH2. There will be a ring. There's supposed to be a ring also present here. Okay. This pair of electron from the nitrogen will attack on nitrogen. So instead of earlier we had the para position of OH. Here again the para position of aniline will form nitrogen bond. Here also this is my secondary. This will again push the electron inside. There will be nitrogen bond. These all three are known as diazo. These are known as azo dyes. Azo dyes. Azo dyes. Very colorful material, azo dyes. Why are they colorful? Because of the extended conjugation. They are colorful material, very, very colorful material. Some of them are used as an indicator also. We have discussed lots of reaction today, everybody, and I am sure you have understood all the reactions today. This is another example. Copper with HCl can form chloro, and specifically for bromo you need to use this set of reagent HBF4 fluoro compound is obtained. This is known as Balch-Schiemann reaction. Balch-Schiemann reaction. NaNO2, Na plus, NO2 minus can also kick away this N2. Remember, N2 is a huge, very excellent leaving group. It's an excellent leaving group. NO2 is present over here. Again, I can use SnCl2 and HCl combination, which will be a source of nascent hydrogen, will satisfy both these nitrogens, will hydrogen each. And the compound formed will be phenylhydrazine. Phenylhydrazine. This is known as beta naphthalene. If naphthalene, this is my naphthalene molecule. This is my naphthalene molecule. If I have OH present here, this is known as alpha naphthalene. Alpha naphthol. Alpha naphthol. Alpha naphthol. Okay, but if it is present here on this position, this becomes beta naphthol. Beta naphthol will again increase the electron density on this particular position, and then attack will happen on this nitrogen. There will be a bond formed. Check please. This carbon center. Earlier it was para. Now it is the ortho center. Sir, why not para? Because para is blocked. Para is already occupied. This is ortho, meta, para. Para is used. So ortho is free. Ortho has to form this molecule. Here it should be nitrogen bond formed, and it should be, one second, there will be that. Yeah, that's all. Should be nothing over here. Clear, everybody? You start with beta naphthol. This part comes from beta naphthol. This part comes from diazo salt, benzene diazonium salt. Reacting with CuHBr also you can form this compound. Reacting with water or H3PO2, water will form OH molecule, phenol. Reacting it with H3PO2 or ethanol or SnCl2 NaOH, they all are going to produce the very basic molecule, the father of all the aromatic molecules. That's benzene. That's benzene. Sir, from here to here, can we prepare benzene? Yes, that's just the use of zinc dust. Remember, H2O forms phenol starting from benzene diazonium salt. And if you want to particularly form benzene, you need to use H3PO2. H3PO2, very commonly used H3PO2. Little bit of heating. That's all you need to use to prepare the desired molecule. That's all for today, everybody. Every single reaction from NCERT is covered. I suggest you to watch this video at least 2 to 3 times so that you are done with all the reactions from NCERT, and this will be enough for your JEE mains as well as for your NEET examination. Nothing else, no other reaction will be asked. That's my word to you. I will see you in the next class, next summary series, everybody. Till then, stay safe. Goodbye.